Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, in this session, I would like to discuss this beam, a continuous beam. Okay, this is indeterminate beam. ABCD. So this beam is fixed at A and is supported by roller at C. So this beam has loaded by various type of loading. Okay, we can see that member AB is subjected by triangular load of magnitude 50 kilonewton per meter. There is an applied moment that is acting clockwise. The magnitude is 350 kilonewton meter, and it also have a point load, a vertical load at D of magnitude 200 kilonewton. Okay, EI, the flexural rigidity as shown in the figure. So this is indeterminate beam, and if we look at the question, we have to calculate the redundant CY, and after that we have to calculate reaction at A. So this is indeterminate beam. By looking at the support, there are 3 at A and 1 at C. So total unknown reaction is 4 unknown reactions. So 4 unknown reaction as usual cannot be determined using 3 equilibrium equation, because only 3 can be determined. Only 3 can be determined using equilibrium equation. So we have in the system one redundant in the system. So this redundant is the problem. So we have to solve the redundant first. And this redundant, in the question given CY as the redundant, so we have to choose CY as redundant. And whenever we choose a CY as redundant, so the beam will we have to remove CY from the system. And when we remove CY, the beam is now called as primary beam. The primary beam is a determinate beam with 3 unknown reaction. The unknown reaction is located at A at fixed. Okay, we have removed roller, we have removed CY, the redundant. So it is just a cantilever beam subjected to various loading. 50 kilonewton per meter, 350 kilonewton meter, and 200 kilonewton. Okay, so this is called as primary beam. Primary beam is a determinate beam after removing redundant from the system. So original we call it as actual beam. Actual beam is indeterminate beam. So once we choose redundant, we have to remove redundant. So redundant, after we remove the redundant, the structure or the beam is changed from indeterminate to determinate beam. So the beam is called as the primary beam. Okay, so in the primary beam, we have to calculate reaction at the support, as well as we have also need to write the moment equation. Okay, so next is redundant beam. So we have primary beam and redundant beam, because whenever we remove redundant, we actually apply the principle of superposition. In the principle of superposition, we divide, we remove redundant, and we plus the redundant, the unit value of redundant in another diagram called as redundant beam. So redundant beam will basically follow the type of primary beam. If beam is cantilever beam, redundant beam also cantilever beam. If primary beam is simply supported beam, the redundant beam also simply supported beam. So in this case, the beam, the primary beam is cantilever beam, so redundant beam also cantilever beam. So we can see that there are two systems. One is called as primary beam, another one is called as redundant beam. Both are cantilever beam subjected to different type of loading. Primary beam is a determinate beam subjected to all external loading, and redundant beam is a system that is subjected to a unit value of Cy. A unit value of Cy. A unit value of Cy. Okay. So why we have to do this? Why we have to do this? This is because after we determine redundant, we determine number of redundant. We have to choose the redundant. In this case, the redundant is the redundant is Cy. So we have to calculate this Cy value and the redundant value. And the redundant can be determined using what we call as uh, using compatibility equation. And in the compatibility equation, which is actually the displacement equation at the redundant position, means that we have to have the displacement, we have to calculate displacement at position C, displacement at position C, okay, for primary beam, not is symbol for primary beam, and FCC is displacement in redundant beam, FCC due to a unit value of Cy. So this is equal to 0. This is actually the compatibility equation. So redundant is 1. So Cy is the redundant. So how to solve the redundant is by solving compatibility equation. Compatibility equation is actually displacement equation. We have to determine displacement at C for each system. We have primary beam, we have redundant beam, we have actual beam, and of course actual beam, due to the roller support, it is equivalent to 0. Actual beam, it is equivalent to 0. So delta C naught is deflection at C for primary beam, and FCC is deflection at C for redundant beam due to a unit value of due to a unit value of Cy. That is why we get like this. Delta C naught plus FCC dot Cy times Cy is equal to 0. So what is delta C naught? What is FCC? So delta C naught and FCC, these two are displacement. These two are displacement. Displacement delta C naught is 1 over EI. 1 over EI. Okay, from 0 to L, we have to integrate. We have to integrate two moment equation. 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 Okay. We have to integrate two moment equation. So actually this is actually we adopt the principle of virtual work, a method to calculate displacement, and we have to adapt into this method. So basically, whenever we want to calculate displacement, we have to integrate two moment equation. We have to integrate two moment equation. So the two moment equation we label as MC M naught dx. So MC M naught dx is basically referring to the notation that we use for the symbol, for the displacement symbol. Delta C naught, and delta C naught means MC M naught dx. We integrate. Okay, and FCC is also displacement. We use the same formula. We use the same formula from 0 to L. We use the same formula. So since the notation that we use here is CC, means that it is MC times MC, so we write as MC square dx. Okay, so since these two, the outcome, the goal that we want to do, the goal that we want to achieve, the goal that we want to achieve is to calculate CY. That is the goal that we want to achieve. And how to achieve this? We have to have delta C naught and FCC. So under delta C naught and FCC, there are two moment equation. One is MC, one is M naught. So what is MC? What is M naught? M naught is moment equation. MC is also moment equation for beam. For beam, M naught. Remember, naught is always the symbol for primary system. Naught is always symbol for primary system. So that is why we have here primary beam and redundant beam. So we have to analyze. We will have two system called primary beam and redundant beam. The primary beam, we will write the moment equation and we write as M because the primary we put the not symbol, and for the redundant beam we will follow whatever notation that we use to representing the moment equation for the redundant system. And in this case, this is MC. So M naught is come from primary beam, and MC is come from redundant beam, or redundant beam is redundant CY applied. That is why we name it as redundant redundant CY applied. We name it as MC. Okay, so we have to, in order to write the moment equation, we have to calculate the reaction at support A, fixed support. So we calculate. So always remember, for the triangular load, the area is the force. So to get 250, it is actually the area is 0.5 times 2 times 50. The area of triangular load, we plus by 200, so that is why we get this 250. Okay, so the triangular load is acting downward. It is 0.5 because that is the formula for calculating the area of triangular, times 2, the distance from A to B is 2 meter, and we times by 50, so we get 50, and 50 plus 200, we get 250. That is why we get AY is equal to 250. Okay, and for the moment, okay, moment is P times L. P is for force, L is distance. So by taking moment at A, so for the triangular load, for P, it is 1/2 or 0.5 times 2 times 50. So this is for P. We have to time with L. And L, we use 2/3 times 2 again. Okay, so acting clockwise. So we have to plus with 350, also acting clockwise. Okay, also acting clockwise. And we have to plus with 200 times 7, also acting clockwise. So the total give us the answer. Okay, it is 1/2 times 2 times 50 times 2/3 times 2. Okay, plus 350 plus 200 times 7. It is 1816 0.667. Okay, acting counterclockwise to get the equilibrium condition. Okay, so that is why I have put actually the value here. So that is the moment value for MA. Okay, considering the triangular load, the moment at C as well as the point load at D time with the distance. Okay, so that's, so the most important thing is not how you calculate the reaction. What most important is the value. So what I want is like this. Okay, the primary beam with reaction value, because from this we will write the moment equation. The moment equation is more important because we use the moment equation into the formula, the displacement formula, okay. Okay, next is redundant beam. For redundant beam, we have the same type of beam. It is cantilever beam, subjected to a unit value of Cy, and due to a unit value of Cy, we calculate reaction at A. So to remain equilibrium, so we will get Ay negative, and Ma for redundant beam is positive 5. Okay, positive 5. So this is actually the two determinate beam. uh, One is called as primary beam, another one is called as redundant beam. One is M naught, one is MC. So after this we will write the moment equation. Okay, so to write the moment equation for member AB, so okay, for member AB, so we will have three cutting section A, B, B, C, and C, D. Okay, when we write moment equation, what most important is origin. So we have to choose the right origin, and always remember at origin X is equal to 0. At origin X is equal to 0. So in this case, okay, for member AB, I choose to use A as origin for AB. BC, I choose C as origin. CD, I choose D as origin. Okay, so by choosing A as origin means that at AX is 0, at BX is 2. So that is how we get limit of AB. So for member BC, origin can be C, origin can be D. So if we choose different origin, we will get different limit. But by taking C as origin for member BC, for cutting section BC, so the limit will be 0 to 3. 0 to 3. And for CD, origin is D, the limit is 0 to 2. Okay, so when we want to write this equation, okay, the cutting section that we should consider is this. This is 250. This is 1816.667. And then the moment is this M naught. Okay, so we have to write this equation. And for the triangular load, this is not 50. No, this is not 50. Because the distance is X. The distance now is X. So we have to interpolate the new value, okay, for this position, and we have to interpolate. So the value is 25x. It means that when we substitute x is equal to 2, it is 50. Okay, so this is the cutting section for AB, origin A, limit 0 to 2. Okay, this is the cutting section. Okay, so by using this diagram, we write the moment equation. So we get 250x. It is 250x. Okay, we minus by 1816.667, and the triangular, remember, it is P times L, the area and the length. The area and the length. The area is 0.5 times x times 25x, and the length is 1 over 3x. The length is 1 over 3x. Okay, so it is 0.5 times 25, 0.5 times 25, we divide by 3. We divide by 3. So we get 4.167. Okay, it is x cubed. For triangular load, we will get x cubed. So this is the moment equation. Moment equation for AB. For AB. And when we move to this, okay, the cutting section here, okay, the moment is like this. So means that we get, and again the cutting section, most important is the right moment equation. The right moment equation. So this is MC. Okay, so having this free body diagram of the cutting section, okay, this means okay, x start at A. Okay, x start at A, so it is 5 minus x. It is negative m plus m minus x. So it is 5 minus x. It is 5 minus x. That is for AB. That is for AB. Okay, that is for AB. Okay, now look at the diagram again. Look at the diagram again. So we want to write the moment equation for cutting section BC. For cutting section BC by taking C as origin. By taking C as origin. So we have 200, and then we have 350, and then this is the cutting section. This is M naught. Okay, remember that x origin is, this is origin. This is origin means this is x and this is 0. Okay, so due to this, what we get is M. What we get is M plus 350 plus 200, 202 plus x. 200, it is 200, it is 2 plus x. Okay, so this is equal to 0, so what we get is m plus 350 plus 400, 350, it is 350, it is 2 plus x. This is 2 meter, this is x, so it is 2 plus x. Okay, so it is 350, it is 350 plus 400 is 750. 750, and we plus by 200x is equal to 0. So we get 750, not 950. It is 750. 7. Okay, it is 750 minus 200x. Minus 200x. Okay. So it is 200. Okay, last one. Last one is CD. Last one. This is 200. This is moment M naught, and this is X, and this is 0. Okay. So this one we will get M plus 200X. So it is negative 200x, negative 200x, so as stated in the table. So most important is the moment equation. Actually all the diagram, the free body diagram of the cutting section, the process of writing moment equation. Okay, that is just to help you to write the correct one, the correct moment equation. But for me, most important is the moment value, the moment equation, the moment equation uh, that you put into the table. That is very important. Okay, so this is for M naught, and we move to MC. We move to MC. MC for member BC. For member BC, the section is going to be like this. Okay, so this is one moment. This is MC. Okay, X is here. This is 0. Means that the moment equation is MC minus 1 times X. So we get MC is equal to X. X. This is correct. Okay, C is equal to X. And for CD, we cut section like this. So the moment equation is 0. The moment equation is 0. So this one is also correct. Okay. So next step after this is we want to determine we want to determine we want to calculate the value. Okay, the compatibility equation is the compatibility equation is it is delta C naught, it is delta C naught P plus by F FCC times CY equal to 0. This is the equation, the compatibility equation. So now we will integrate the moment equation. And don't forget to EI, we have EI to EI and EI. Okay, so we can solve in terms of EI, but we have to consider uh, this EI into the formula. Okay, the EI to EI and EI. So that is not constant. Okay, so for delta C naught, okay, this is equal to 1 over EI is 1 over EI is 1 over EI Okay, we integrate. Okay, for member AB is 0 to 2, from 0 to 2, 0 to 2, and it is 5 minus x. It is 5 minus x times with this one. Actually, you don't have to write the equation. You can just use calculator and calculate the value. Okay, so that is for AB. That is for AB. So we plus with BC. For BC, it is okay. It is x times, okay. So this is dx, and this one we have to divide by 2ei. 2ei, and we have to plus. Okay, actually we have to plus another one CD, but since MC is equal to 0, so I think we don't have to write that one. So we just can solve the answer for delta C naught by only considering this, because for CD, MC is equal to 0. Okay, so use calculator and we determine the value. So it is 0 to 3 for the second one. Should be 3. Okay. Okay, let's calculate the value. We integrate 5 minus x times with 250 minus 116.667 minus 4.167. It is cube. X cube. Okay. X cube. We put the limit from 0 to 2. Okay. Okay. The first one is negative 12590. So we have to plus with another one. Another one. So it is negative 12590 0.007. Okay, we divide by EI. Divide by EI. Okay, we divide by EI. And this one we have to plus another one. Another one is the grade, it is x times negative 750 minus 200 x from 0 to 3, and we divide by 2, so we get negative 2587.5 over EI. EI. So the answer is, so we get so this is equal to negative 15177.507 over EI. Okay, so this is the answer for delta C naught. Delta C naught. So we repeat the same process to calculate FCC, and then once delta C naught and FCC have been determined, so we just need to substitute into the compatibility equation. Compatibility equation. Okay, then by solving this equation, we get CY value. So that is the answer for A. That is the answer for A. We calculate the redundant CY value. Okay, so that's all for the first session discuss on this beam example, beam question. So we will continue for the second question. How are we going to calculate the reaction at A after we have determined CY, the redundant? Okay, and because we can solve the remaining reaction after we solve the redundant, we normally can continue to calculate using equilibrium equation. But in the next video, I would like to share with you, beside equilibrium equation, we also have another method, uh, another option, which is more, uh, what can I say? It is easier than using equilibrium equation for some cases. Using principle of superposition to calculate remaining reaction uh, will be more easy, okay, than using equilibrium equation. Okay, so that's all for the first part. We will continue for the second part after this. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.